So in this video, I wanted to go over running an example provided by Nordic on their GitHub page. Under one of the repos is a coded PHY demo showing the long-range feature of Bluetooth 5. And this utilizes the UART example that existed before. However, it's modified to for both the central and the peripheral to utilize the coded PHY feature of Bluetooth 5. So you would go to this repo here, which I have already open. So in this repo, you would either clone it or download it, and make sure you place it in the SDK examples BLE central and peripheral folder. So let's take a look at that, where it's located with the in the folder that's provided by the ebook as part of the GitHub project. So this is the root of that project, and if you look here, you can see inside the NRF SDK we go into examples, and then we place it in BLE central and peripheral. So you'll see that this is the actual folder that I downloaded from GitHub or cloned, and inside it is the example. So once you do that, you can open this project in SES. If you navigate down to PCA 10056 S140, the EM project, and make sure in this case that you are running on the NRF 52840. Otherwise, this is not going to work, because this is specifically using the coded PHY, which is available only on the NRF 52840. So once we open that in Seger Embedded Studio, I connected both devices to my computer. I turned off one just so I know which one is being flashed, and I flashed both devices. One of them, the central, what I'm going to do is the central, I'm going to run it in debug mode here in SES, and the peripheral, I will have it connected to CoolTerm here as a serial terminal to see the output. And what I'm going to do is send a string through this UART and verify that it gets received on the central end. Now in this beginning video, in the beginning of this video, throughout right now, I'm going to do this while both of them are pretty close to each other in proximity. However, later on I'll add a video showing at least connectivity between the two devices, and add that to the video at the end. So let's first let's go and take a look at the code pretty quickly and just explain what's different here, what's modified from the original UART example, which is a simple example that allows you to type in, connect the dev kit to a terminal, type in data that gets transmitted through UART to the NRF chip, which passes it on over BLE to another device, and then that other device can choose to display that on the UART connected to that one as well. So the main thing here is in the both, since this example runs on both sides, the way it's actually this example, there are two examples inside this. There's the UART-C, and so this is the central in this case, and then there's the UART without the C. C stands for central here. And so I have both of them are included in the same folder. So if you look inside here, you'll see that there's a BLE app UART-C and a BLE app UART. And once you open that in the central example, you'll see that when it's in the scanning parameters, that's where it sets it to utilize the coded PHY. So scan PHY is set to coded PHY. So this is the PHY to scan on, and that's it basically. I mean, this is the example that shows how you can scan and then connect on the coded PHY. So if you search for coded, I believe it's just that. That's how it's configured, and that's how you can run this example. So once you do that, on the other side though, so let me flash this. So I'll keep this open. I'll go ahead and actually open the other one and show you the what's happening on the peripheral side. So if I go to, let me go to the folder and open it from there, it will be easier. So in here, if I open up not the UART, not the UART-C, and open this up here and double click, it should open up in Segur Embedded Studio. And now you see this is open. Inside this main, if you look at the code, the main parts that are modified here is the advertising start, which defines that the primary PHY and the secondary PHY are both coded, and the legacy PDUs turned off. So if you look at what this means, this is just advertise using legacy advertising PDUs, which are this is using extended advertisements, and it's advertising on both the primary and the secondary, and it's using coded PHY for both. So if you look in here, once we connect, we should see in the connection events, we should see where it requests a well, actually, if it's connecting, it would actually connect on this PHY and stay connected. Nothing changes, nothing needs to change later on for the connection. Yeah, so all that happens is you set the advertisement to be on this, using this PHY, the coded PHY, which is for the long range, and once the other device finds it, which it won't be able to find these advertisements unless it's tuned to the coded PHY as well, they can connect to each other and stay on the same PHY. So let's go ahead and just run this example. So again, I'm going to be running the UART-C, the central part, inside Segur Embedded Studio, and I've already flashed the other one, the peripheral side, which I'm going to connect here. So if I go to CoolTerm, I have the peripheral only turned on right now, so I can easily find it and know which port it's on. So let's just do a rescan just to make sure. It shows up here. We have to choose 115/200 and connect. And let's reset the board just to make sure that it's running. And you can see it's running. Now let's go to, another thing, I'm going to turn this off now, so you'll see it's disconnected. And the reason I'm going to do that is because I'm going to connect the other board. And I know this may sound like a hassle, but it's just safer to connect one board at a time. So if I connect the other board here, I'm going to open up the solution, the project for the central side. So if I go up here and choose the central, go into S140 SES and open up. Just make sure that it's built up to speed. When I first, another note is when I first cloned this, I had to modify the RAM start and the RAM size variables in, under options. And I go through this in the chapter on setting up the development environment. There's a section on NRF, I guess, troubleshooting tips. And one of them is adjusting the common linker macros, the section placement macros. And if you connect the device and run it and make sure that the debug is on and RTT is enabled, you'll be able to see if it runs into issues and it needs you to modify the start and the size. So I had to adjust those, and then once that's done, if you run here, you'll see that it's running fine, and it looks like the BLE UART central example is started. Let's go back to here. I have it turned off. I'm going to turn it back on and just reconnect, reset it, and let's see. Okay, so I have the UART here printed. I have everything here as well showing. One other thing I wanted to also mention is that in the SDK config.h, and you can do this from the SimSys configuration wizard, but what I have to do is increase the default, the NRF log default level, because it wasn't showing the characters being received over UART. So if I increased this, it was at 3, I modified it to 4, I started getting more messages and it would show the text. So this is the central device running. This is all running over coded PHY. This is the peripheral, and as you can see that it detects that it's connected. So what I'm going to type is, I'm just going to type test message, and it doesn't show up here until I press enter. And when I do that, this gets transmitted to the other side. So if you see here, what you see here is the app on the other side, on the central side, received the data and prints out the message that we sent. So that's all I wanted to go through. Just wanted to also, make sure, or at least point out that it's pretty simple to add and support the coded PHY and do the long-range mode in using the NRF APIs, the soft device APIs. Just make sure you have the correct soft device, because this is using an upgraded version of the soft device, but it's it's included within the repo itself, so you wouldn't have to worry about that if you want to start with this example and run with it in order to develop an application that utilizes coded PHY. That would work. So the advertisement and connection happen over coded PHY. There was one thing I wanted to mention, was that make sure that you are running both sides on the NRF 52840 boards. And if you, for example, the peripheral side will be advertising, but it's using extended advertisements. So if you try to scan for that, those advertisements using your mobile phone, NRF Connect or something, as of now, it's not going to find that, because your phone probably won't support Bluetooth 5, at least finding the advertisements yet. I know some of the phones do have the BLE, the Bluetooth 5 chip inside of them, like the iPhone 10, the iPhone 8, and Samsung Galaxy S8, I believe. However, I don't know if the APIs for Android and iOS are supporting that yet, and I'm not sure what the plan there is. But if you have two boards connected, you'll be able to verify this and run this example. So that's it for this tutorial. I'll add another video here shortly to kind of show this demo live over a longer distance. Thank you for watching. Okay, so what I have here is two NRF boards, and one of them is running the UART client or central application for the long-range demo, the coded PHY in Bluetooth 5, and the other one is running the peripheral side. So here's the central side. This is the device. It flashes the LED 1 when it is scanning for the other device. The other device is currently off. It's turned off, and it's connected to another computer with a serial terminal to show the data. The use case or the example is by testing sending data across the UART. Typing in something on one side from the computer goes through the UART to the NRF board, which gets transmitted over the coded PHY, the long-range mode, over to the other board, which transmits it back out to the UART and displays it on the computer. So what we're going to do is I have the central running here, and the other side is turned off. It is connected to a computer with a terminal, and we're going to walk over to there. You can see it's at a pretty long distance. I haven't measured it yet, but there's a lot of metal objects in between as well. And it's not quite line of sight, so this can prove to be a good test to see if the coded range. Another test would be interesting is to switch it to using the regular UART and see the difference between the test results. So I have the board here. It's currently turned off, as you can see, no LEDs, and the terminal. Oops. And what I'm going to do is I'm going to turn it on now, and we should see the data come in. Let's see. For some reason it didn't display the data. Oh, I may have to connect again. Okay, so I'm going to disconnect, and then connect the port again. This computer is pretty old, so bear with me here. Okay, and Let's connect. I'm going to reset it just so, okay, so I just reset it. So it should have lost connection. It's should be flashing the LED 1 as well. Indicate it's advertising. Actually, it doesn't flash, it just goes to the connected mode. So it says here that it's connected. So before we go back, let's try typing something. So I'm going to type, let's see, long range test. And once you type, you have to hit enter for it to show up on the screen. And now it showed up here. And this is the peripheral side. It still shows that it's connected. You can see the LED. So let's go back and walk over to the central side and double check and see if the data made it or not. It'd probably be interesting to test this at a much longer range as well. Possibly with more walls in the middle, or at a more line of sight but farther distance as well, maybe outdoors. But looks like the central still says it's connected, and voila, if we see here, we can see that the text was transmitted successfully. So that shows us at least a proof of concept of how coded works, coded PHYs in Bluetooth 5 between two NRF 52840 boards. Thanks for watching.